Hello folks, we come to the miscellaneous exercise of chapter 8 and we are now taking up the part 2 video. We have finished the question number 1 and 2, now we are taking up the question number 3, and the question number 3 is a pretty lengthy and tricky question in which they ask us to find out the coefficient of x raised to 5 in the expansion of 1 plus 2x raised to 6 into 1 minus x raised to 7. It's a product. Expanding both the terms, multiplying it and then finding out the x raised to 5 terms, sorting out their coefficients and getting the answer. That's the elaborate procedure of doing this problem, but that's not advisable. It is not necessary to do so much of steps. We analyze both these expansions and just trace out the terms where we could be probably getting x raised to 5, and from there we could get the coefficient and then we could do the work. That much of work only is advisable. There is no need to be doing it so elaborately because it's too much of working. Having it expanded, then having it multiplied, then sorting out the x raised to 5 terms is almost not so advisable method. So let's check this expression and let's try to see how we can do this. We consider the product first. We are considering 1 plus 2x raised to 6 and 1 minus x raised to 7. We analyze as to what all cases we are able to get x raised to 5 as a coefficient. I mean x raised to 5 as a term. So under what all cases? If there could be an x raised to 0 expression here, and if there could be an x raised to 5 expression here, if they were to be multiplied, then you would have got an x raised to 5 expression, right? Similarly, if there was an x raised to 5 expression here, and if there was an x raised to 0 expression here, if they were to be multiplied, that also would have given you x raised to 5. If there was an x raised to 4 expression here, and if there was an x raised to 1 expression here, they would multiply and they would have given you x raised to 5. Why? Because a raised to m into a raised to n is a raised to m plus n. Similarly, x raised to 1 expression from here, x raised to 4 expression from here could have given you an x raised to 5. Another possibility is x raised to 3 expression from here, x raised to 2 expression from here, and vice versa, x raised to 2 from here and x raised to 3. These are the possible cases where you would have got a coefficient of, where you would have got an x raised to 5 terms. So it's enough if we find out their respective coefficients, multiply it and get the answer. So we will consider for this expression the terms where x raised to 5 is obtained. Yeah, these are the terms where x raised to 5 is obtained, and simultaneously we will also consider its coefficients. Right. Now, an x raised to 0 term from here, because it's a second thing, will be x raised to 0 means the first term where you don't start with this. So the first term is always nc0, we know. So the first term will be nc0, which is 6c0. And you don't have anything from that side, so that is not there. So that is the coefficient, and then you have to get the coefficient of x raised to 5 from here. If it has to be x raised to 5 from here, it's very clear that it should be 7c5. That's very clear because of the second term. So 7c5, and then that minus you have to account for, minus 1 raised to 5. So that is about the first term. Then we can see the second term. If you have to get an x raised to 5 from here, then it has to be 6c5, and because 2 is there, that 2 raised to 5 will come. Correspondingly here, it's the first term, so that is 7c0. So that much is done. X raised to 4 from here, so it is quite logical now. It is 6c4. X raised to 4 means it's a fourth term, so 2 raised to 4 also you'll have to account for, and x raised to 1 from here means obviously it is 7c1, and minus 1 you have to account. Same way, x raised to 1 from here means it is 6c1, 2 raised to 1. Here you have to account for 2, and there you have to account for minus 1. So those things you should be careful. Then here it is x raised to 4. So x raised to 4 means it is 7c4 and then minus 1 raised to 4. The x raised to 3 term here means it is 6c3 and 2 raised to 3. And this is x raised to 2, which means it's minus 1 raised to 2 and 7c2. Okay, then we have x squared term here, which means it is 6c2 and then 2 squared. Because it's a cube term here, it is 7c3 and it is minus 1 raised to 3. Okay, we will by and large see which are the negatives and which are the positives. This is a negative term, this is a negative term, and this is a negative term. There are 3 negative terms and there are 3 positive terms, and we will also find out the C values so that it will be easy for us. We require a 7C5. Here, let's find out. A 7C5 is as good as 7C2, and that is going to be 7 factorial by 5 factorial into 2 factorial. 5 factorial is getting cut 6 into 7, and that 2 can get cut 3, so 21. So 7C5 is done. Then we require a 6C5, that we know is 6. 6C5 we know is 6. Then we require a 6C4. 6C4 gives me a remembrance that it's 15. And then 7C1 we know is 7. Then 6C1 we know is 6. We know it's 6. Then 7C4, that we need to find. 7C4 is 7 factorial by 4 factorial into 3 factorial, which can be 4 factorial can get cut 5, 6, 7, and this is 6 actually. So that can get cut 35. So we are done with 7C4. 6C3, we do remember that it's 20. 7C2, do we remember? Yes, we have it here. It is there. And 6C2, yes, it is 6C2, which is 15. And 7C3 is the same as this. So we have all the values. So that now we can substitute and we can get the value. Required value. Let's write. Therefore, the required value, let's have the additions first and the subtractions later. So 6C5 into 2 raised to 5 into 7C0 of course is 1. 6C5 for us is 6. So this is 6 into 32. We all know that 2 raised to 5 is 32. The next positive term is this. 6C1 we know is 6 into 2 into 6 into 2 into 35. 6 into 2 into 35. 6 into 2 into 35, right. Then the next positive term is, let's check, the next positive term is this one. So that is 6C3, which is 15 for us. Yeah, 6C3 is 20 for us. 20. And then this is like 2 cube, which is 8. And then this is 7C2, which we have it as 21. So many values are there. Now all the subtraction values. Let's club them together and write. 6C2 of course is 1. 7C5. 7C5 for us it's 21. So only 21. Then because we've put the minus outside the bracket, then we can always take all the pluses there. This is a negative term. 6C4 for us is 15. So this is 15, this is 16, 2 raised to 4 we know is 16, and this is 7. So that is done. Then we have the next negative value, this 6C2. 6C2 for us it's 15. There is a 4. Then there is a 7C3 which is 35. So we move and we see how we can do it. So that's about all this. And then now let's solve this. 32 into 6, it is 6 2s are 12, 18 and 1 19, first term. 35 into 2 is 70, so this will be 420. Then 21 into 8, let's have it. 21 into 8, 168. So 168 into 2, it's going to be 8 2s are 16, 6 2s are 12 and 1 13, 2 1s are 2 and 3, so 3360. Yeah, that's our first bracket. Let's take the second bracket. 21, that's effortless. Then 15 into 16 into 7. So we could have probably 16 into 7 or whatever. 16 into 7, 42, 4, 11. 7 is 7 and 11. Then we can have the 15. These are small values, you can take directly. 15 twos are 33 carry. 15 ones are 1518. 15 ones are 1516. 1680. And the last one, 15 fours are 60 we know. So it's 35 into 6. 6 fives are 30. 18. 18 and 3, 21. So 2, 1, 0, 0, 1, 0 from the 60. So like that you have these many values. Now let's see how to get this solved. We have over here 192, 420 and 3360 as a first bracket, and then in the second bracket we have got to have all this 21, 1680, and you have to have 2100 to be added up. Let's see what comes. Here we get 2, 6 and 2 it's 8, 8 and 9 is 11. 6 and 2 it's 8, 8 and 9 is 17. 7, 8, 9. 3972. Let's check here. 1, 10, 8, 3, 3801. Next it is to subtract. 3972 minus 3801. 2 minus 1, 1. 7 as it is. 9 minus 8, 1. 171 is your required answer. So this is how we go about doing this. It's a tricky problem, and one has to be careful about the kind of working that you take up for this. So that's 171. And then we can take up the fourth problem. Fourth problem says that a minus b is a factor of, you have to show that a minus b is a factor of a raised to n minus b raised to n. You have to show that it's a factor. And as an aid in the question itself, there is a hint in the textbook. They say that you consider a raised to a as something like, okay, let's start right away. Consider a as a minus b plus b. Definitely minus b plus b is cancelling. You are left with a. It's as good as saying this. Having considered this, they say you consider on the same lines. You can consider a raised to n as a minus b plus b whole raised to n. You are getting the exponent n there. Having got this, you will look at it in the binomial way by splitting these and then work it out. So let's work out directly. This will come to nc0 a minus b raised to n. This is nc1 a minus b raised to n minus 1, but b starts. nc2 a minus b raised to n minus 1, and b becomes b squared. So on. Our last term we know is ncn. There is no first term, but there is that b raised to n. Now, whatever, wherever possible, let's try to simplify. nc0 we know is 1. So it's like a minus b whole raised to n. And this is n. N times a minus b raised to n minus 1 into b plus nc2 a minus b raised to n minus 1 b squared, and so on. The last term ncn we know is 1. So that is b raised to n. So literally what we have got, a raised to n is all this. This is what we have got. They ask us, okay, they have asked us to show that a minus b is a factor of this. So why not take this term on the other side? The plus b raised to n will go on the other side, it will become minus b raised to n. And we have all the other terms here. A minus b whole raised to n, n times a minus b raised to n minus 1, nc2 times a minus b raised to n minus 1 b squared. Now here, because the last term has gone, we'll write the penultimate term, which is ncn minus 1. A minus b would be there once, and there would be b raised to n minus 1. Right. Is there any striking feature in the right hand side? Do we see anything striking on the right hand side? Is there any number which is there in all the terms? Yes, a minus b. It's definitely there with different powers, but it's definitely there in every term. There is one a minus b here, there is some power here, there is some power here, there is some power here, but it's there in every term. So as a result, a minus b is a factor. That's what the question says. isn't it? So there is no harm if we write the a minus b outside, if you take it common. That's how we take common. When there's something commonly occurring in all the terms, you take it out and the remaining terms stay inside the bracket. So we take a minus b out, and probably you will have a minus b in the first n minus 1, in the second powers get n minus 2, and last term would have nc n minus 1, which could write it as n also, only b raised to n minus 1 surviving, because you've pulled out that common term there. So that's about this. So you have it common, and therefore a minus b is a factor of a raised to n minus b raised to n. That's all about this part 2 video of ours, where we did 2 very important problems, strategy wise very important this problem, and this is intelligent application of binomial theorem. With more problems, we are coming in the next video. Thank you.